Today we're solving two types of equations. One's with log and one's with no log. Okay? So if equations have logs in them, like 1a, this is how we're going to do it. Okay? So it says solve. So anytime it says solve and there's an equal sign, first thing we're going to do is draw a line down from the equal sign, like we always do. Okay? It's a log equation. It's got the word log there and log there. They both have the same base too. So the last 2 days, we've practiced condensing and expanding. Okay? So if I wanted to condense those two, I could. How do I do that? You use the power property, product property, or quotient property. You can use one of them, two of them, three of them, doesn't matter. Okay? So the first thing I'm going to do is I have a 2 in front. Where did that 2 come from? Where was that 2 originally? It got moved to the front, but originally, where was it? It was with an exponent, right? It was with the 3. So first thing I'm going to do is I'm going to put that back. That's the power property. That's what you guys did last 2 days. So that 2 is supposed to be there. So it's supposed to be 3 to the second power. Okay. Now, the 2 logs are attached by a plus sign. Which one of the properties with the plus sign? Quotient, product, or power? The product multiplication went with plus. So now what I'm going to do is I'm going to combine those 2 logs using the product rule. The product rule says you can condense using multiplication. So 9x times 3 squared. Well, 3 squared is 9 times 9x is 81x. Okay. That's step 1. Condense the log. I should write condense, not combine. Condense, because that's what we did. Condense. Okay. Now we're done with that. Next thing, get rid of the log. Convert it to an exponent. How do I get rid of a log? What do I need to do to get rid of a log? We haven't done this in a few days, but we've done it plenty this chapter. What do I do to get rid of a log? The loop trick, yeah. You guys did it last week. We haven't done it this week, but last week you did it, right? Start with the base, go to the other side, loop back. 5 to the second power equals parentheses. Five to the second power is 25. Step 2 done. Step 3, solve. Well, there's only one way to do it. There's only one thing to do. Divide by 81. Now, 25 and 81 don't share anything in common. Don't share any numbers besides 1 in common. I can divide 25 by 5 and by itself. I can't divide 81. 25 and 5 don't go into 81. So I'm done. Don't change it to a decimal. Just leave it like that. One thing we do have to do for logs is check for extraneous solutions. We haven't done this since last chapter. I think last chapter we did extraneous. And the chapter before that. We've done a few chapters. So how do we know if it's extraneous? This is how we know. We're going to plug our answer back into the parentheses. If I get a negative, extraneous. If it's positive or 0, I'm okay. Well, I can't plug it into 3 because there's nowhere to plug it into. So the only thing I got to plug it into is 9x. Okay? So I'm going to check here. I'm going to plug in my answer into the parentheses. Can't plug it in for 3, so I'm going to check here. If I get a positive number, it's okay. If I get a negative number, it's extraneous. Okay, so I go to my calculator. You can pretty much tell it's going to be a positive because it's a positive times a positive. 9 parentheses 25 divided by 81. Oops. Close parentheses. I get positive 2.777. I don't really care what the number is. I just care that it's a positive number. It's a positive number. Okay. Since it's a positive number, one box, 25 over 81, done. If that was a negative number, extraneous. We're going to get some that are negative. Okay. All right, let's look at letter B. Okay, going to draw my line down the equals. Okay. They both have the same log 2, log 2. So I know I can combine them. I know I can condense them. Question is how? How do I condense them? Well, I got a minus. What did we do to condense them yesterday when we had a minus in between them? Division, right? Yeah, we used division. So I have log base 2, the top, divided by the bottom. Okay. Condensed it. It's only one log. When you only have one log left, you've condensed it. Next step, convert it. No more log. I don't want a log. Okay. So I get 2 to the 4th power equals the fraction. Two to the 4th power is 2 times 2 times 2 times 2, which is 16. Okay, so we haven't done this for a few chapters. We did this, though. We've done this semester. How do I solve this guy? What am I going to use? See if anyone remembers. What am I going to do to solve this guy? What's the step I'm going to do? Yeah. What was that called? It's a certain type of multiplication. It started with a C. Cross multiplication. You're doing diagonal multiplication, right? You got to turn 16 into a fraction. It's a fraction equal a fraction. So I'm going to do diagonal multiplication or cross multiplication. So I'm going to multiply these two guys. And then I'm going to multiply these two guys. And equals in the middle. That's how to get rid of those two fractions. So the pink is going to be 1 times 3x squared minus 3. The orange is going to be 16 times 2x plus 2. Distribute. 32x plus 32 equals 3x squared minus 3. Two questions. How many answers am I going to get? Two. Good. You guys remember that. We're going to get two answers because there's a squared there. Okay. How do I get those answers? How do I get that? What do I have to, what's my next step going to be? Here you go. Set it equal to 0. Get everything on the same side. Everything on the same side. Because it's either going to be a binomial or a trinomial. That's what it's going to be. If I get two answers, it's always going to be a binomial or trinomial. Okay? Well, this guy is going to be A, right? So I'm going to keep that positive. So what I'm going to do is I'm going to get these guys over here. So to do that, I got to do the opposite. So subtract 32x from both sides. I can't subtract it from either of these guys because it's an x, not an x squared or just a regular number. So where does it go? It goes right in between. And then I'm going to subtract 32 since it's positive. That one I can subtract from 3, negative 3, because they're like terms. Minus 35. Okay. Okay. So it's a trinomial. It's got three terms. 3x squared, negative 32x, negative 35. So the second one, factor out a GCF. The first, I can divide 3 by 3, but negative 32 and negative 35, 3 doesn't go in. So no GCF. Leading term has to be positive. The guy in the front has to be positive. Yep, he's positive. ABC. We haven't done this in a while, but we have definitely done ABC. 3, negative 32, negative 35. So the top is going to be A times C. 3 times negative 35 is negative 105. B goes at the bottom. So I got to come up with the two numbers that multiply to be negative 105 and add up to be negative 32. Let's see. I'm going to go negative 105. It's our division. I know 5 goes into it. Let's see, 5 plus negative 21, that's not going to make negative 32. It's not quite big enough. Okay, 15. 15 plus negative 7, no, that's not big enough either. 25 doesn't work. 35. 35 plus negative 3 makes positive 32. Well, what if I make this guy negative? Negative 35 plus 3 makes negative 32. So that's the one I want. Negative 35, positive 3. They multiply to be this guy, the top. They add to be the bottom. Box. Remember, first term, 3x squared, goes in the first box. Last term, negative 35, goes in the last box. And then the two guys I just came up with, go in the other two with x's. Now I got to figure out what multiplies to be 3x squared. Well, x times x, 3 times 1, right? Well, I got to have a 3 on the side or a 3 on the top. A 3 on the side, on the left side, won't work because 3 doesn't go into negative 35. There's nothing, 3 times nothing makes negative 35. So 3 has to go up here because 3 times positive 1 makes positive 3. And then negative 35 times x makes negative 35x. So I get 3x minus 5 and x plus 1. What's the last step to get my two answers? Oops, 35. So it's supposed to be 35. 3x minus 35. Yeah, how do I get what's the step I need to get my two answers? Set them equal to 0. Yep, set them both equal to 0. So I get 3x minus 35 equals 0. X plus 1 equals 0. Add 35 to both sides. Subtract 1 from both sides. So I get negative 1 as one of my answers. The other one's going to be a fraction because 3 doesn't go into 35 evenly. So I'm just going to leave it 35 over 3. I'm going to pause there for a second because I got to check to see if any of those are extraneous. Now this part you can just do in the calculator. You don't have to write this part down, but make sure you check because I've seen lots of times people put both answers and it says wrong. They're like, well, I didn't do anything wrong. Got to check. Okay, so how do we check? This is how you check. I plug in both answers into the parentheses. So I go to my calculator. So the first parentheses said 3 times x squared minus 3. The second parenthesis said x squared, 2x squared plus 2. I'm going to plug my answers in there. One of my answers was 35 over 3. 35 divided by 3. 35 divided by 3. Both of them give me positive answers. 35 over 3 is okay. $35 over 3 is an okay answer. The other answer I got was negative 1. Negative 1. Negative 1. Get 0. 0 is okay. 0 is not negative, so it's okay. It's okay. Negative 1 isn't okay. It's barely okay, but it works. Doesn't give me negative. So that guy's okay as well. So 2 boxes. 35 over 3 is in one box. Negative 1's in another box. Okay. All right, so let's go to the back. All right, so we got 2 logs. They both have the same base. They're connected by a plus, so I can condense them. Since it's a plus, it's going to be product. So log with a base of 3, and I have 2 things being multiplied, x minus 2 and 4x minus 7. It's multiplication. Okay. Okay, can't condense it anymore. Done with that. I only got one log. Now convert. Loop trick. 3 to the first power equals those guys. So 3 to the first power equals x minus 2 times 4x minus 7. Well, 3 to the first power is just 3. What am I going to do with the two parentheses, guys? How do I simplify those to get to solve? No, almost. That's yeah. Distribute. How did we do this? Yeah, how did we do this at 2 terms times 2 terms? Put them in boxes, yeah. It is distributive property, but we just use the box for this one. So this guy over here, I'm going to put a little side note over here because we use a multiplication box. X minus 2, 4x minus 7. Okay, multiplication. 4x times x is 4x to the second power. 4x times negative 2 is negative 8x. Negative x times 7 is negative 7x. Negative 7 times negative 4 is positive 14. Or sorry, negative 7 times negative 2 is positive 14. Combine like terms. Add those together, and I get negative 15x. Okay. It's going to get 2 answers again, squared. So set it equal to 0 like we did last one. Subtract 3 from both sides. Plus 11. There's nothing I can divide that goes into 4, negative 15, and 11. There's nothing there. So skip GCF, ABC. 4, negative 15, positive 11. Okay, so 4 times 11 is 44. Negative 15 goes down here. So now I got to come up with the two numbers that make 44. I can divide it by 2, so 22 and 2. 11 and 4. I think 11 and 4 are the ones. They just have to be negative to make negative 15. 4x squared, positive 11, negative 11x, negative 4x. So for 4x, to make 4, you can go 2 times 2, or you can go 4 times 1. I'm not going to use a 2, because if I put a 2 to the left, it goes in here twice, but it doesn't go in here. It doesn't go 2 times a decimal makes negative 11. I don't want decimals. So I'm going to do 4 and 1. So that'll be negative 1 and negative 11. Okay. Now I can set it equal to 0. I'm going to get 2 answers. From having done this problem last period too, I can tell you right now we're going to get one of them will be extraneous, one of them will be an answer. So we got to check. We're going to have extraneous on this one. Add 11, add 1. So I get positive 1 is one of my answers. And positive 11 over 4 is the other one of my answers. So I did this problem last period too, so I know one of them is not going to work. But if you didn't, you got to check. So how do I check? Go back up to the top, put them in the parentheses. Put them back into the parentheses. So the first parentheses was x minus 2. So I'm going to go to my calculator and I'm going to build these. X minus 2. The other parentheses was 4x minus 1. 4x minus 1. So the first answer I got was 11 over 4. So I put in 11 over 4. I get positive 0.75. 11 over 4, I get positive 4. Those are okay. 11 over 4 is a perfectly good answer because I got positive logs. Now I'm going to put positive 1. I get 2 negatives. I only needed 1, but both of them are negative. That means that's extraneous. That means positive 1 is extraneous because I can't have a negative log. It creates a negative log. That's why. So the only answer I would put is at 11 over 4. Hit enter twice, one box, you're done. Okay. Okay, so that's what we do if you have logs in your equations. Now look at the last set. There's an equal sign, but there's no logs, right? So I can't use the same steps. What do? Well, I'm going to show you what steps to do. First thing we do, draw an equal sign, or draw a line down the middle. Okay. When I don't have logs, this is what I got to do. I have to create the same base. So right now, I have a base of positive 2 and positive 16. I want to change those so that they are the same base. Okay, so 2. The only way to make 2 using powers is 2 to the first power, right? I can't do anything else. There's no other power. 1 to no power is going to give me 2. That's it, right? Can I rewrite 16 so that it's 2 to a power? 2 to the fourth power. Now notice, I haven't changed 2. 2 is still 2. 16 is still 16. I just changed the way they look. Now, they also have exponents that are already there, right? So write those down. So what was the rule for a power to a power? Because I have a power inside the parentheses and I have a power on the outside of the parentheses. How did I add those, subtract those, multiply those, or divide those? Multiply. Yeah, you multiply. So I'm going to multiply times both. So I get 2 to the 2x plus 4. I get 2 to the 8x plus 12. Or sorry, not 8x, 4x. You just distributed the powers. 1 times 2 is 2. 1 times 4 is 4. 4 times 4 times. Okay? So we made them the same. We simplified. Last thing, forget the 2's. I don't need the 2's anymore. The 2's I know are the same. I want the parts that aren't the same. 2x plus 4, 4x plus 12. Solve. Well, it doesn't have a squared, so I don't need to do that anymore. Just get x's on one side, get numbers on the other. So I'll get the x's on the right side. I'll get numbers on the other. Done. These guys can be positive, can be negative, can be 0, can be anything they want. So I don't have to check these guys. So if it doesn't have a log, you don't have to check the answer. These guys can be whatever they want. They're free to be whatever they want. Logs can't be negative. Okay. Okay, so we're definitely going to do B. I don't know if we'll get to C. I definitely want to do another one like this. If we don't finish the last one, oh well. Okay, but I definitely want to do one more like this because the next one has a fraction. What do we do if they have fractions? Same thing. Okay. There's no log. So it's not these steps. Got exponent. Okay. So my two bases, 1/9 and 81. Let's start with 81. Is there a way to write 81 so it has a power? And it's still 81. 9 to the power of 2, yeah. 9 squared, right? Is there a way to write this guy so it's got a power, so it's got a 9 to a power? So what power does 9 at the bottom have right now? 1. How do I get rid of the fraction? What were the rules for getting rid of the fraction? If I want to move it up, turn it to a negative, right? So that would be -1 power. So 1/9 is the same thing as 9 to the -1 power. Step 1 is done. Bases are the same. That's the hardest part about this, getting the bases to be the same. Move everything else down. This guy also has a 5x minus 3. This guy also has a -x plus 14. Distribute. -5x plus 3. -2x plus 28. Done with the big guys. Done with the powers. I don't need the powers anymore. They're equal. I already know they're equal. Set those guys equal to each other now. -5x plus 3 equals -2x plus 28. You can add 5x to both sides, or you can add 2x to both sides. Doesn't matter. I just added 5x to both sides just to make x positive, but it doesn't need to be. Subtract 28 from both sides. -25 over 3x. X equals -25 over 3, which is like a decimal Don't change it to a decimal. Leave it like that. It's negative. These guys can be negative. Big deal. The logs can't be negative, but these guys can be. Okay? So I don't have to check those. We're not going to do C, but I do want you to tell me. I want you to do step 1. Step 1 is the hardest part. So step C, I have this guy. This is about as hard as they're going to get. I'm not going to go the whole step because step 1 is the hardest. What I want you to do is which base are they going to have the same? This is how I do it. Start with the smaller guy. And just play the guess and check. 7, 7, 7, 6. See, let's say 2. And let's pick a big power. 10. Needs to be bigger. Oops. No. 11, 12, 13. Went too high. So 2 isn't going to work. Try a 3. That's too big. Too big. Too big. That one's close. Too big. So 3 doesn't work. Let's try 4. Too big. Trying to make 7,776. Too big. Ooh, close. Too big. 5 won't work because it doesn't end in a 5. So let's try 6. There it is. 6 to the 5th power. So 7, 7, 7, 6 is 6 to the 5th power. But it's not going to be positive 5. It's going to be negative 5. Why is it going to be negative 5? Because, yeah, it's on the bottom, right? To move it up, it's going to be on the bottom. That's the hard part. Now that you know that, it's going to be 6 to some power. Guaranteed, it's going to be 6 to some power. So it's just going to be a bigger power. 6, 7. Let's try 7. That's too big. Let's try 6. There it is. Okay. And go from there. Okay. That's the hardest part about this. It's not the any other steps. It's just step 1 because sometimes they're big, so it's hard to figure out which bases they have. Okay. There you guys go. Okay. Yep. No problem. I'll finish this one out since we got time. I'll finish it out. Mm-hmm. B, sure.